Herzlichen Dank. It's on? Yeah. So I'm a physicist, but I've loved demography ever since the very first time I ever played SimCity. And I really love that tonight I get the chance, finally, to tell everybody about the connection between physics and demography. So the title of the talk is Electric Lighting and Demography, but a better title might have been Kill Your Alarm Clock! Das geht nicht. Okay, and we'll see why in a minute. But let's start off with the physics part of it. So, how many of you in this room in the last month, say, have seen the moon outside? So maybe something like half, a little bit more. Okay. How many of you have had the experience in the last year where you were outside and there was no electric light, the only light you had was moonlight? There's quite a few. Okay, that's cool. But not everybody. Now we come to the Milky Way. How many people in their life have seen the Milky Way where it wasn't just kind of some kind of cloud in the sky, but it was really the Milky Way with all these patterns and thousands of stars everywhere? And how many have never seen the Milky Way like that? So about half and half, a good fraction of the crowd. The reason that most of us haven't seen the Milky Way is because the light from our cities goes in the sky and scatters back down again. It's too bright to see the Milky Way. And if you went back 200 years ago before you had electric lights and you asked these questions, then everybody who was over a certain age, old enough to go outside at night, would have seen the Milky Way. And if we come to when we first had electricity, then we would have started to have had people, kids, who had never seen the Milky Way before. But in fact, at that time, I gotta say, the cities actually turned the lights off when the moon was out. And so everybody would have known where the moon was, where it was. Everyone would have seen it in the last month. And if we come to today, huge fractions of the population have never seen the Milky Way. And if we go further, there will eventually be 100-year-old people who never in their entire lives have ever seen the Milky Way. Now, seeing the Milky Way, how much does that really matter? But what we see here is that there's been a massive demographic change in terms of our own personal exposure to light and darkness. And this makes a shifting baseline. So if you took people from 1320 instead of 2013, and you showed them this sky, they would think it's normal. And if you showed them what the sky looks like over Berlin today, it would seem really bizarre, and maybe even terrifying. And the reverse also happens. So if you take today in New York City, and there's a power outage, and all of the lights go out, then people phone the police on their cell phone and say there's this silver orb over the city, and I think that must be what caused the power out. But you maybe shouldn't laugh at them, because it makes sense if you've never been exposed to it. So over time, because each generation experiences a different baseline, we can dramatically change what we think is normal without people really noticing it. So let's come back to the clock now. Out of this audience, who doesn't need an alarm clock on a workday? Very few. There's a few. The people who don't need an alarm clock are called larks in English, and the rest of us who do are called owls in English. And so but why is that we all need alarm clocks? Because when my mom was a kid and she was growing up on a farm without electricity, they didn't need alarm clocks back then. Well, Homer Simpson can help us explain it, because here's Homer watching a TV show in the afternoon. It's nice out, blue skies. And he liked the show so much, when it was rerun later that night, 12 hours later, he watched it again. And what's the difference between these pictures? It's just outside. So what we see is that inside during the day, it's never bright, it's just dim. And inside during the night, it's never dark, it's just dim. And we've traded our life with a really bright sunny day and a really dark night for a life of perpetual dimness. And because of that, our body doesn't know anymore when we're supposed to wake up. And so while before we had electric lights, there was maybe 2 hours separating the people who woke up early and the people who woke up late, now there's very easily 6 hours between the extreme people. And that has real demographic consequences, because the larks are far more likely to become medical doctors and graduate medical school. And the owls are far more likely to end up having problems with drug and alcohol abuse. But this is really unfair. It's not that you're a good person that you get up early, it's your physiology that determines that. And we shouldn't decide who gets to be a doctor based on who has lucky genes. So we can measure where you are relative to the other people your age using the Munich Chronotype questionnaire. And everything's in German. You can do this. It only takes a few minutes, and find out how you compare to other people and how much your sleep deficit is. And if you do that, and you work out for everybody in the city what their good time to wake up is, you can make it so that all of the different jobs people have, all the schools they go to, are determined based on when they ought to be waking up. And this is a great idea because, while it wasn't mentioned in the last talk, getting enough sleep is another key to a long life. And the fact that we're all using alarm clocks to wake ourselves up when we really don't need to be doing that is also a public health catastrophe that very few people ever think about. So you can move to Bad Kissingen. The only downside of living there is that you have to live in Bavaria. So this is Berlin at night. We're going to switch now from inside to outside again. And you see that in the former East and the former West, there's still different colors between the city. And that's because it takes tens of years for cities to change their lights over. And the Senate of Berlin is planning on making everything white eventually. And I just want to show why that might not be such a good idea. This is security lighting someone has in their backyard. And if we take some of the light away, suddenly you can see that somebody's standing there. And that's a problem of glare. And I'm going to show you sort of how glare works. Here's a typical street where some of these lights are shining into someone's bedroom window, the other side of the street shines in the other bedroom window, not very good for sleeping. And they also shine all the way down the street into your eyes. So that does two things. First, your pupils get smaller. And that makes everything seem darker, because when you have bright lights, it makes your pupils get smaller. The second thing that happens is actually much worse. It's that the light scatters inside of your eyeball and goes in all directions, and it makes everything kind of gray. And when you put these two things together, you end up having really terrible vision on the street. And the older you get, the worse this problem gets, because more light scatters in your eye. And if you use white light, it makes the problem also worse, because bluish light is more likely to scatter. So if you've ever been outside and seen one of these cars with those bright blue headlights and it bothered you, it wasn't the brightness that bothered you, it was the fact that it was blue. So when we design these streets, we need to be thinking about the older people and the fact that everybody's getting older. Because if we keep on designing bad streetlights, then a lot of people won't be able to drive at night anymore, even though if the streetlights were designed well, they would have no problem. So what's it look like when a city changes the lamps? Well, you just put the light down where it's needed, onto the street, and you don't shine it way down the street where it's glaring, and you don't shine it in people's bedroom windows, and you don't shine it into the sky. By doing that, you save a huge amount of money and electricity, and you also will bring back a huge number of stars into your city. So the last thing that I want to tell you today is that I am running a crowd-financed project for Berlin school kids. They'll get little light meters, they'll go outside at night with their parents and measure how bright the night sky is. And by doing that, they'll get really great, useful data from me. I'll go into their classrooms and teach them about sustainability and urban design and the physics of light in the atmosphere. And they will also get the chance to go outside with their parents in an urban area and do stargazing, which is something that almost never happens inside of the city. So if you think that's a cool idea, pick up a flyer on the way out. They're at the window over at the last edge. And it's crowd-financed, which means that I try to convince 1,000 people each to give me €5. And there's only 5 days left for me to finish it. So if you think my talk was cool, please pick up a flyer, tell your friends on Facebook. And if it was really great, then send me €5. Danke für die Aufmerksamkeit. Thank you very much to the people who provided pictures, to the BMBF for providing me my job in Germany. And finally, the Milky Way would really love it if sometime this summer you took a trip outside the city and lay down on the grass and looked at the stars. Thanks.